Good evening, everyone. So today we start the next part of circular motion. And my topic is centrifugal force. So basically, what is the basic difference between centripetal force and centrifugal force? Means when the centripetal force apply and when the centrifugal force apply. You can remember it in with the very basic logic. The basic logic is that if an object is moved, or if an object taking a circular motion within a system, then you can apply centripetal force. But if the system is rotating, try to understand, if the system is rotating, then apply centrifugal force. I just give you one example, then you understand. Suppose death well. So death well is a system, right? So if you are rotating around a death well in a circular motion, so then you are applying centripetal force. Clear, everyone? Then you are applying towards the center of force. This force is called the centrifugal. Okay? Hello? Similarly, suppose this is our earth and the earth is rotating in its own axis. The earth is rotating in its own axis with some angular speed, and you are on the surface of the earth. So now system is rotating and you are on the system. So you are realizing a outside force, because you also are moving in a circular motion as the earth is rotating. So you realize an outside force that is called centrifugal. The value is same, mv square by r, v equals to r omega. So here we can use m r omega square by r, that is m omega square r. Clear, everyone? Hello? Understand?
Yes, sir.
Suppose a fan is moving, okay, and you can tie a string with the fan with a bob. So when the fan is moving, the system is rotating. So the bob on that fan, it will be moving outside, right? You understand what I want to say? Suppose a ceiling fan is there and 3 blades are there. They are rotating in a circular motion, right? If you put a string and a bob, so as it will start moving, it will move outside. Yes or no? Like this. Yes or no? Yes. So that is called centrifugal force. I can give you one more example. Suppose you have a tube, very small tube like this, and you put a bob here with a string, and here you put another bob. Without touching the string and bob, how you touch this bob here? How you touch this bob here? Tell me. The best thing is that you have to hold the bob like this. You have to hold the pipe like this and rotating like this. Yes, when you're rotating, that means you are rotating the system. As you rotating the system.
এটা বুঝলাম না।
আমাকে দেখতে পেলি আমি কি বললাম?
না স্যার, এটা বুঝলামই না প্রথম থেকে, মানে এই কোশ্চেনটা।
এটা এরকম পাইপ আছে, পাইপের উপরে একটা মাছ আছে, নিচে একটা বড় মাছ আছে, নিচে মাছটা এরকম ঝুলছে। এই মাছটাকে এখানে কি করে সাঁটাবি? পাইপটাকে ছাড়া কোনো কিছু ধরতে পারবি না। তো পাইপটাকে ধরবি, এরকম এরকম করে ঘোরা। ঘোরালে কি হবে? স্ট্রিংটা এরকম গোল গোল করে ঘোরা শুরু করবে।
হ্যাঁ স্যার।
এটা ঘোরা শুরু করেছে মানে এইদিকে যাচ্ছে, এটা আস্তে 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 নিচের দিকে চলে যাবে, উল্টে দিলে কিন্তু নিচে পড়ে যাবে, বুঝতে পারলি?
হ্যাঁ স্যার।
So if you rotate this like this, so m omega square r, this angle is theta, m omega square r cos theta, and this one is m omega square r sin theta. So this one lifting this one, and as well as it will be bigger and bigger, and it will be moving up and touch here. Clear?
Yes sir.
Okay. Now, two questions are there from this centrifugal force. Very, very important two questions are there. So I would like to give this question, because centripetal and centrifugal, if the force apply outside, then it is called centrifugal. Like by using this process, वो घी से मक्खन को निकाला जाता है, घी को क्या करता है सर्कुलर मोशन में घुमाया जाता है, तो जोर में जब सर्कुलर मोशन में घूमता है तो सिस्टम इज रोटेटिंग, तो सिस्टम में जो है लाइक जो 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 इसमें जो मक्खन है उसका वेट जो है ज्यादा होता है, तो वो क्या करता है बाहर की तरफ छिड़कने लगता है, ठीक है। एक क्वेश्चन है देखो, वेरी गुड क्वेश्चन from this centrifugal force. Question is that a tube of length L is filled completely with an inextensible liquid of mass capital M and closed at both the ends with a uniform angular velocity omega. Find the rotate with angular velocity omega. Find the force exerted by the liquid at the other end. तो ये एक लिक्विड है, ये एक ट्यूब है, इसको हम लोगों ने एंगुलर मोशन स्टार्ट किया विद द वेलोसिटी ओमेगा। ठीक है, L is the length of the tube. L is the length of the tube. इसका मास m है, इसका यहाँ पे कितना फोर्स लगेगा, means what is the total force applied on the tube. So how you solve this type of question? Whenever examiner give you this type of question, first क्या करना है, हमें एक small elementary part लेना है. Let the thickness is dx, which is at a distance x from the center. So इस पे force कितना लगेगा, centrifugal force df, which is outside because it is moving, the whole system is moving. Inside this the force is up outside. Formula क्या है, dm v square by r. Here r is, we can take x because we are taking x as a distance from here to here, and v equals to omega x. So I can write dm omega x whole square by x, that is dm omega square x. First thing. Now the second thing is that dm, how you get the value of dm? Dm, this is the mass dm. Total mass, how much? Capital M per unit total length into thickness. What is the thickness? Dx. So if we put this value, what we have, mass per unit length into dx omega square x, that is m omega square L x dx. Yes or no? Hello, yes or no?
Yes, sir. Yes, sir.
Now taking integration both sides, 1 by 2 into 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 find out the total force. That is, m omega square L integration of x dx 0 to L, total length here 0 to F. So what you have, F total force is m omega square L x square by 2 0 to L. That means m omega square by L square minus 0 by 2, that is half m omega square L. Which one? No?
স্যার তুমি একবার শুরু থেকে একটু বোঝাবে একবার?
হ্যাঁ, দেখ আমাকে এই পুরো অবজেক্টটার মাস দেওয়া আছে m, मास यूनिफॉर्मली डिस्ट्रीब्यूट আছে, এর লেंथ হচ্ছে l, এটা যখন ঘুরছে इसका जो हर एक जगह है, हर एक जगह पे अलग-अलग स्पीड होगा, बिकॉज वेलोसिटी इक्वल्स टू एंगुलर स्पीड इनटू पोजीशन.
Yes sir.
So we imagine elementary part dx. Why we take length? Because the mass is lengthwise distributed. So we imagine the small elementary part dx, which is at a distance x from the starting point. So for that small part, what is the force? Small force. What is the value? Centripetal force. So mass is dm. V square is the speed by position. Now we know speed equals to omega x. So we can write omega x whole square by x. So we have dm omega square. Ek x cut gaya, so x. Now that dm is the mass of that small elementary part that we don't know, but we know the total mass, we know the total length, and we know the thickness. So I am find out this small mass in terms of total mass per unit total length into thickness. Now, mass per unit length into length, we get the mass of
Yes,
that
sir.
small part. So I am putting this value, mass per unit length into thickness, omega square x. So what we have, mass omega square L, this whole are constant, only x and dx is variable. So to find out the total force, we can take integration. So we are taking integration from here to here. So from here to here, the force is variable because speed is variable. So I am taking x dx integration, and we know the integration of x power is 1, to 1 plus 1, 2 by 2. I'm putting lower and upper limit. So m omega square by L, L square minus 0 by 2, that is half m omega square L. Clear?
Sir.
Now I can give you one shortcut method for that. See, at that point, your force is 0. Why? Because no length is there. And here, if you see the force, that is m v square by r, that is m v is r omega square by r, that is m omega square r. And r is L, sorry. Now, so here the force is m omega square L, and here the L is 0. So the force is 0. So that force is variable with respect to L. So you can find out the average force, that is initial plus final by 2 without calculator, without calculation, sorry, without calculus method, 0 plus ml omega square by 2. So the answer is half m omega square L. Same answer आया ना? तो हम लोग जो नॉर्मल इंटीग्रेशन करता है, that is the average value. ठीक है? Okay,
Yes,
everyone.
sir.
Now I want to give you one more question, and for that, actually this question is from NCERT book. So for that you need a calculator, because you can see what happened. I'm giving you the question. Question is that a disk revolve with a angular speed a disk समझते हो ना, CD disk player. This is a disk revolving with angular velocity. A gramophone, angular speed 33 1/3 revolution per minute, or you can say 100 RPM revolution per minute, and has a radius. इसका जो radius है इस gramophone का radius is given 15 meter. Sorry, 15 centimeter. 15 centimeter. Okay. Two coins are placed at 4 centimeter and 14 centimeter away from the center of the record. Center of the record. If the coefficient of friction between the coins and record is, if the coefficient of friction between the coin and the record is 0.15, which of the coin will revolve with the record? माने यहाँ पे देखो simply, मानो मैंने एक coin रखा है, ठीक है? क्वेश्चन में दो coin है, one is at 4 centimeter, another is at 14 centimeter. तो बोल रहा है ये दोनों में से कौन सा कॉइन रिकॉर्ड के साथ रहेगा. ऐसा भी हो सकता है दोनों कॉइन ही गिर जाए, ऐसा भी हो सकता है कि दोनों कॉइन ही रहे, ऐसा हो सकता है दोनों में से कोई एक कॉइन गिरे. So how you do that? That is the main idea, right? So one thing we know, as the record is rotating and the coin is on the record. So first of all, the coin realizes a centrifugal force mv square by r. If we say v equals to r omega, so that is m omega square r. Yes or no? Is it clear?
Yes.
Devolina, বুঝতে পেরেছিস?
হ্যাঁ স্যার।
So tendency of the coin on the record player is moving outside because the system is moving with some angular velocity. As I already mentioned you, if a system is moving and you are on the system, so you are realizing centrifugal force. माने मने कर जे तू एक satellite है, तुम लोग एक satellite में चढ़ गया है and satellite is rotating earth, so you are realizing centrifugal force. Why? Because the satellite is moving itself and you are on the satellite. Okay, like we are realizing a centrifugal force because the earth is rotating in its own axis. Now as the tendency of motion in this direction, the mg of the coin is acting downward, normal reaction is upward, so frictional force acting this direction. Yes or no? Yes or no?
Yes.
Acha. To stay the coin on the that disk or on that record, to stay the coin on that record, frictional force must be greater than centrifugal force, because frictional force holding the block from centrifugal force. If the centrifugal force is greater than frictional force, it will be throwing out from the record. Yes or no?
Yes, sir.
Devolina bujli? Ayan buchhish?
হ্যাঁ স্যার।
Ayan? Ayan? Shoumitri? Manish?
Yes, sir.
বুঝতে পারছিস তো? Frictional force is greater than centrifugal force, then and only then the coin is on the record. Otherwise, if the centrifugal force is greater, then it will be throwing out. তো তাহলে আমাকে কি দেখতে হবে? আমাকে দেখতে হবে frictional force at least equal to centrifugal force, that the distance we get. If the coin is more than that distance, it will be moving out. If the coin is less than that distance, that directly proportional na, r যত বাড়বে তাহলে আমার frictional force centrifugal force বাড়বে. If my r is decreasing, centrifugal force decreasing. So if I get that exact location, if that is the point where they are equal, so if you stay beyond that, you are throwing out. But if you are staying within that, so you are safe, means frictional force adjust that centrifugal force. Yes or no?
Yes, sir.
So that means we can say mu mg is equals to m omega square r. So I can cancel this r, and according to question we have to find out r, that is mu g by omega square. Now see, you can realize yourself, omega, that is 100 revolution. One revolution is 2 pi radian by 60. So I can cancel this, I can cancel this 3. So I can get 10 pi by 3. So I can solve it by two methods. One, I can take mu 0.15, then I can take G10. If no calculator is allowed, then I can take 10 pi by 3 whole square, and then I can write 1.5 into 9 by 100 into pi square, that is 1.5 into 9 by 100, and the value of pi square is 10. You can calculate this, at least easy, you can calculate that part. Now you can check, calculate and tell me, but according to NCERT, because they using exact value, so they use 0.15 into 9.81, 10 ka square, that is 100, 3.14 ka whole square into 9. And when you solve this after calculator use, I get the value 0.1215, that is 12.15 centimeter. Anyone tell me what is the value of this one? Anyone tell me what is the answer? So we get the value 12.15 centimeter. So clearly 14 centimeter is beyond this 12.5 centimeter. So this one is fall down, and this one is less than 12.5 centimeter. So this one is stay with the record. Yes or no? Everyone, yes or no? So circular motion का एक part बचा है, that is although not called circular motion, that is actually है work power energy में, ठीक है, vertical pendulum. So we see this after work power energy or at the end of the work power energy. So today we start that chapter, at least give some introduction of that chapter, that is work power and energy. Huh? So I'm starting with that chapter. Work power and energy. So first we can define work. And how you define work? Work is said to be done whenever a force acts on a body and the body moves through a distance in the direction of the force. In the direction of the force. That means, what do you mean by that? Suppose a body is placed here and you are applying the force. Due to that force, if the body move, then only. If the body not move, then no work is done. Suppose the body move, S displacement. So force along the displacement, and displacement is called the work done. When a work is said to be done, whenever a force acts on a body and the body moves through some distance in the direction of the force, or you can say in the direction where the object moves, in that direction फोर्स का डायरेक्शन में मूव करना या जिधर मूव कर रहा है उसके डायरेक्शन में जो फोर्स लग रहा है, बात है कि हुआ ना? हेलो, मैं फोर्स इधर लग रहा हूं लेकिन ऑब्जेक्ट तो इधर नहीं मूव कर रहा है ना, ऑब्जेक्ट इज मूविंग फ्रॉम हियर टू हियर, so the force is applied along the direction of movement. Clear? Is called the work done. So work done is force along the displacement into displacement, that is Fs cos theta. And when you write this Fs cos theta, you can realize some important things. Am I audible properly?
Yes, sir.
I can do one thing.